In this video, we'll be taking an odd turn for this project. We'll be creating some abstract art on the mill purely as a way to test our skills in different milling operations. I will also be using this project as a marketing ploy to go follow me on my other social media channels like Odysee, as there is a more in-depth version of this work with more detail over there. Before we get too deep into this, let's do a quick thank you to Speed Tiger for helping us make this video possible. As this project will be a test of our skills for numerous types of operations, we'll start with a 5/8 inch thick slab of aluminum like this, or whatever thickness you have, and we'll be facing adaptive clearing, pocket milling, and even drilling. Make sure they have a perfect matching milled bottom on them, so they are a matched pair when done and sit at the exact same height when displayed. As you can see here, we have drawn out some abstract designs on both of the pieces. Doing two different designs helps us create some visual interest in the piece, obviously. If you want to display them together back to back, you can also put some matching holes. This would allow you to use some gauge pins or precision shoulder bolts to connect them if you wanted to, say, have them be displayed somewhere that they can be viewed from all angles. If you do choose to connect them with shoulder bolts, you can opt to place some nut-shaped recesses on the back of the holes. If you did, say, 1/4 inch holes like I did, then I suggest doing 10/24 sized nut recesses on the back, as shoulder bolts in the 1/4 inch size are generally cheaper with a 10/24 threaded bottom than they are with a matching 1/4 20 threaded bottom. Now that we've got that, let's talk about the way that we are going to tackle this particular project. Now, I'm not going to go through both of them because they are literally the exact same tool paths, just done for slightly different shapes. Mostly we'll be using specifically tools for aluminum, an 1/8 inch, a 1/4 inch, and a 3/8 inch. We're also going to be doing a little bit of work with a chamfer mill just to hit those edges. So when I talk about those are the 4 bits that we're going to be utilizing here. We're also going to use some drills and a reamer, but we'll see those in action. All right, really simple strategy to go at here. For the first one, we're going to start on the top face, and that's after you've squared up stock if you have to and whatnot, obviously. We're going to face off anything that we need to face to get to the proper thickness. Mine ended up being about 0.63 inches thick, if I remember correctly. And then we're going to go ahead and do our drilling. So this is a 0.241 inch diameter drill bit. I think it's a letter C drill bit. And the reason I went with that is that gives me about 0.010 of an inch between what I drilled and between what I'm going to ream. Let's get into the actual milling though. We're going to do an adaptive clearing path only down far enough so that we don't hit the vise, obviously. We don't want to ruin bits today. And then we're going to come around after doing the adaptive clearing, and we are going to just do a contour path to get everything nice and clean. While we're here, let me show you what my feeds and speeds were for this aluminum 3/8 inch bit. I've shown people my feeds and speeds for the 1/8 and 1/4 of an inch bit and the chamfer bit till the cows come home in other videos. Go watch them there. But here's the information that I've been using for this 3/8 inch bit. I gotta be honest, when you listen to it, I'm probably pushing this bit a little harder than I should, and I'm not getting the surface finish that I want. My gut is actually that the dimension that I'm pushing it too hard in is the offset that I cut, the width that I cut when I'm doing the adaptive clearing. So I probably will keep the feeds and speeds where they're at, but in the future I will likely knock down the amount that I'm cutting each pass. I think I've got it set to 1/8 of an inch. It's pretty aggressive. Either way, moving on, we're going to keep that 3/8 of an inch bit, and we're going to adaptive clear out the entire left-hand section here. I actually did it in 2 paths because I wanted a nice clean floor, so I did the bulk of the work at 1 speed. And then I did my finishing at my finishing profile. We then swapped out to a 1/4 of an inch bit and cleared out all of the various little route downs that we needed in order to allow the lower to sit flush. Last but not least, we chamfered absolutely everything because I don't want any burrs or edges. Flipping over, let's talk about how we did the back of these jigs. So again, we're just going to run a facing path to get it to our preferred thickness. Then we're going to run that 1/8 of an inch bit to clear out all of these nut holes. Might think back to the drilling operations that I did before. If you look at how deep they went, there we go. They only went to the bottom of the material, but they have a tip on them. So they didn't actually fully poke through. I didn't care because when I came back and did these nut recesses, that opened everything up. I do then have to come back around and clear out all the excess edging that was left over from where I was using the vise to grab onto things. Again, I just used a 1/4 of an inch bit here and cleared that out, and again, put a chamfer on everything. And there you have it, our finished result. If you got all the way to the end here on YouTube, then I again recommend checking out the longer, more in-depth version over on my other social media channels like Odysee. I think you'll really enjoy that exclusive extended director's cut there. I'll be curious to see what wonderful abstract designs other people dream up and mill.